So you are all here for Exchange. So Microsoft Exchange Server, virtualized on vSphere. That's what we're going to talk about. We're going to, I've been giving this presentation for a few years now, and it used to be about 67 slides. And I used to get through about 45, and have to distribute the slides out and take all the questions out into the hallway. I'm really going to try to get this in about 45 minutes so we can get folks. There's microphones here I see, so hopefully we can get some good Q&A going. I'll try not to rat hole the conversation too much, as I have been known to do in the past. So I won't spend any time on this slide. Right to the agenda. I said that this was the presentation that I used to give had a ton of information, ton of slides. I nailed it down to just the best practices. I spend pretty much every day talking to customers that are either looking to design Exchange on vSphere in the middle of a deployment, maybe troubleshooting a deployment, but troubleshooting a migration that's already going on, whether or not the issue is because of virtualization or not. And I hear the questions that come up constantly, and so I've tried to narrow it down to what I hear and the best practices, and hopefully we can nail a lot of the questions that are on your mind, and if not, then I will leave some time for Q&A afterwards. So quick look at the agenda. We'll go over some Exchange design on vSphere. That's probably the number one question I get. I already have a design. How do I migrate it, or how do I even begin a design on vSphere? Really quickly go into support considerations, just because it's something that still comes up constantly, surprisingly, but maybe not so surprisingly since it's changed so much over the last few years. It tends to still be a confusing topic, so we'll just look at that really quick. We'll cover some best practices. We'll look at one of the hot topics, which is HA, DRS, and vMotion, especially when we're talking about Exchange DAGs and DAG nodes. We'll look at some best practices from that perspective, and then we'll look at site resiliency and some data protection. So the design process. One of the first things that I come out and tell a customer or anyone that I'm talking to about designing Exchange on vSphere is, regardless of what the underlying infrastructure is going to look like, we're still designing Exchange. And that's not going to change, right? We might have some more options, but at the core of it all, we're still designing an Exchange environment, and the requirements aren't really going to change, right? We still have a static set of requirements, whether those are business, technical requirements, high availability requirements, number of users, things like that. So we need to understand that. So like I said, we need to look at some of the prerequisite information. Do we need high availability? How much high availability do we need? Do we know the workload that we're going to be deploying into this or migrating to this new Exchange environment? Because everything's a migration now, right? There's no more upgrades. Do we know the health of the infrastructure around Exchange that it's going to be dependent on? Do we have to do any upgrades to that environment? And then are there any support and licensing considerations? Support and licensing, at least in a lot of the documentation that we do in the business critical apps practice at VMware, always go hand in hand. Licensing doesn't really come into play so much with the virtualization of Exchange Server because it is still the simple server cow model. You can spend a whole hour at a session for something like SQL or Oracle licensing. Exchange is a lot simpler than that. We need to follow a design methodology, right? First and foremost, we need to establish the design requirements, and we'll take a look at some of those in a minute. We need to gather the compute requirements from an Exchange perspective. Typically, that takes the form of going through an Exchange calculator design process. So, downloading the Exchange calculator from the Microsoft Exchange team website and going through the input parameters there. We can then start looking at designing the virtualization platform where this is all going to run. And part of that is really understanding what type of hardware are we going to use, what features of the virtualization platform are we going to employ there. And then we can start looking at how we're going to carve up these virtual machines. Right? We have many more options. We're not designing Exchange to run on a static set of hardware. Right? We're not designing Exchange to try and fully take advantage of that 12-core box with 96 gigs of RAM. We don't need to, right? We can make adjustments there. So what are some of the design requirements? I mentioned high availability and how much high availability you really need. We've all kind of jumped onto the cart that Microsoft's pulling and said, we're just going to do DAG no matter what. And that's fine. DAG is a very, very good technology, and to be completely honest, 95% of the designs that I'm involved in are focused around DAG. It really makes sense, especially with the I/O improvements that have happened, starting with 2007, 2010, and even more so in 2013, just around the corner here. You're able to get the amount of storage that you need to go with a DAG design for a lot cheaper than you used to be able to. So it's a very good design. But you also have things like vSphere high availability. And I said 95% of the customers that I talk to, or 95% of the designs that I've been involved with, there are some customers that just don't see the need. VMware IT is actually one of them. They went from my time that I spent at VMware IT for 5 years, since 2005, it was a really cluster-centric environment, and everything got clustered. Exchange was clustered for a very long time, up until about a year and a half ago. They finally made the decision because their clusters were, and they were not 2010, so disclaimer there, but their clusters were so troublesome to them that they made a decision because they didn't really have any application outages based on Exchange. Everything was really, something happened with the cluster. Something went wrong. They made the decision to switch over to a non-clustered Exchange environment. A couple of designs for 2010 that I've been involved in have done the same thing. They've chosen to go with a single mailbox role, no DAG, and they're using vSphere HA for high availability. They can get away with things like that because what does the DAG get you, right? It gets you an additional set of databases that are redundant. So it'll protect you from corruption, not so much, not very prevalent in Exchange environments, but the server outage, right? That's your form of server failover. So customers that are able to justify a maintenance window, so they don't need to have their services up and running while patching, are able to take advantage of vSphere HA. Customers that can sustain a maybe 2 to 3 minute outage while a server reboots, all right? These are VMs that we're talking about. They boot up very quickly. Those customers are able to take advantage of a purely vSphere HA environment for Exchange. Another important characteristic of those customers is that they have a way of backing up and, more importantly, restoring large amounts of data very quickly. This could be using array-based snapshot technology or clones. But those are typically the three factors that come into play when we're looking at kicking DAG to the curb and going with the vSphere HA environment. Again, a very small population. We need to look at site resiliency requirements. Again, are we going to go with a DAG-based solution or maybe something else, maybe Site Recovery Manager? Are we going to co-locate any of the roles? That's going to have a big impact in sizing of our VMs or whatever it is we end up running on. Database sizing is important because we need to look at how are we going to back up that data, right? Are we going to go with very large databases, and we need to now figure out how do we get that data backed up and, more importantly, again, restored very quickly? How many mailboxes, and what are the mailbox profiles? So I just put together a really quick example of what we go through during this design process. I'm not going to spend a whole lot of time on this. Everyone will get the slides. But basically, what I've pumped some data into the Exchange mailbox calculator, and I've basically said I have 10,000 users. I'm just going to have a single site. I want DAG for availability, and I'm going to dedicate my mailbox role on a single VM or a single instance of Windows, whatever that ends up being, and I'm going to combine the client access and hub transport servers. I'm able to actually see out of the calculator that this, in order for me to support 10,000 users, 10,000 active users, I need to have 7 processor cores available. The way that that's calculated in the Exchange calculator in the spreadsheet is based on a number that we need to provide, which comes from the spec website. The spec website provides throughput numbers for specific processor cores, specific processor models, and in many cases, the specific server running that processor that you're looking to run. That's a requirement of the calculator so that it can actually give you, as accurate as it can, the number of cores required to run your workload. So what the calculator is basically telling me here is that if I'm going to run 10,000 users on one instance of Windows on one Exchange server, that server is going to have 7 cores. Now, if I am looking at a clustered solution, I'm effectively doubling that. So I'm going to end up with 14 cores. In case I have one failure, I can still run everything on one VM. The same thing somewhat is the case for the client access and hub transport servers. However, if we remember the previous slide, I needed 7 cores to run my client access / hub transport services. I can get that in 2 very large VMs, just so they're redundant. I can build 2 8 vCPU VMs and have that redundancy there. I could also go a little smaller, right? I can start scaling them out and maybe go with a few 4 virtual CPU VMs. And now, let's say I deploy 4 of those, and these are the numbers that are kind of going through my head when I'm going through a design like this. If I can deploy 4 client access / hub transport servers, and I give them all 4 vCPUs, well, if I lose one, I still have 12 vCPUs worth of client access hub transport server going there. All right, and those smaller VMs tend to work a little better, especially if I'm trying to use things like DRS, right? So I then, just to touch on the memory real quick, 256 gigs of memory. That's a lot of memory. The calculator said I needed 128 to support 10,000 active users. So if I am looking to go with that 2-node DAG, and I do have a DAG failure, I need to be able to have that 128 gigs on a single VM. And this is where I start thinking about other numbers. Okay, what happens if I start scaling out? Then I might be able to reduce that memory footprint on a per VM basis. 48 gigs of RAM for the client access and hub transport servers, that number really just comes out of best practice from Microsoft. Allocate 2 gigs of memory per core or per vCPU, and an additional 4 gigs for the OS and the apps. I then start thinking about a sample vSphere configuration. Right, I'm going to start making little VM blocks out of these numbers and start placing them on vSphere configurations. I just chose a 2-socket 6-core box because that seems to be pretty prevalent these days. And then, of course, the vSphere minimum requirements after I add everything up. And add an additional host for HA. So I end up with something like this. And this is typically the first scenario that I would put out there. Just as few virtual machines as possible, as few vSphere hosts as possible. The problem here is that although during normal runtime, I actually have some compute resources left over, if I have a failure, I'm going to be in an overcommitted situation. Now, I can actually go back to this scenario. I need the extra compute on the right side for the client access hub transport servers, but really, if I were to lose one host and I didn't bring up that second DAG node, I would really be in the same boat as I would have been in a physical environment. I still have all my users running on a single VM, and that VM has been sized in a way that it's capable to run all 10,000 users. Typically, the design that we're more inclined to go with is a bit more of a scaled out model. So in this scenario, we actually design a 3-node DAG. And in a 3-node DAG, I only need to allocate 64 gigs per VM. And I can take the number of vCPUs down to 6, because now in a single VM failure scenario, my 10,000 users are split across 2 DAG nodes, not on 1. That also gives me the capability to have some extra capacity at the compute level so that I can host other services like my public folders, any BES, if I still have BES servers, public folder servers, anti-spam, maybe I have postfix servers, or even Exchange Edge. So we end up giving customers, or when we start looking at these designs, we take a few options and we play with the numbers a little bit. But really, the main idea here is, again, we're always looking at the Exchange side first, and we then start drilling down from there. We work the Exchange side, we figure out what the requirements are from an Exchange perspective. We then start looking at the vSphere environment and understanding are there any limitations there, are there any considerations because we're going virtual. And then we start playing around with the different building blocks, some of the flexibility you have there by going down the virtualization route. So on to support. So really quick, after Exchange 2010 Service Pack 1, really the the floodgates pretty much opened up, right? There was a lot of, with Exchange RTM, the list of limitations was pretty significant on the TechNet page that lists out the requirements for Exchange 2010. You couldn't use hypervisor-based high availability with DAGs. You definitely couldn't vMotion them, things like that. So where we are today, just to make it very simple, virtualization of all server roles is supported with Exchange 2010 Service Pack 1. The additional role that was added at that time was the Unified Communications role. Combining Exchange 2010 SP1 DAGs and HA, hypervisor-based high availability, and vMotion is supported. Now, the vMotion or the live migration or whatever that particular hypervisor calls it, using that feature with the DAG node or the clustered VM needs to be supported by the hypervisor, but Microsoft is okay with us doing that. From a disk perspective, you can use either virtual disks or raw device maps, also known as pass-through disks. And then from a storage protocol, there really hasn't been any restrictions except for the first one on the what is not supported section. So NAS, right? Mainly for a vSphere environment, what we care about is NFS. So NFS-backed virtual disks continue to not be supported. That's still the case even in 2013. Using thin virtual disks continues to not be supported. And virtual machine snapshots for the case of Exchange level restores. One of the questions that pops up is, well, I use a third-party backup solution that actually takes a VM level snapshot and then streams that off. Yeah, there are technologies that do that. However, the difference is those actually tend to be Exchange aware. So what typically happens there is we'll have an agent that lives within the VM, which does the orchestration of calling VSS, making sure that Exchange is quiesced, making sure that the required database consistency check that happens after a VSS backup completes successfully, and then actually goes in and truncates the logs. Right? A simple VMware snapshot doesn't do any of that. So we want to make sure that if we are looking at any backup solution that is going to leverage VM level snapshots, they are Exchange aware and doing the required tasks that an Exchange aware backup would normally do. So best practices from a virtual CPU perspective. First and foremost is making sure we're not overcommitting the server hardware immediately, right off the bat. During design, we do not want to design with the intent that we're already going to overcommit at time of deployment. There's kind of two reasons for that. The calculator that we're using from Microsoft isn't assuming any level of overcommitment of the hardware. Now, there is a drop-down where you can say, is this deployment going to be on virtualized hardware or isn't it? And what that really does is it triggers Excel to basically add 10% or whatever the percentage is that you're filling in for virtualization overhead into the calculations. That number isn't really well defined. In our last batch of testing, which was done with Exchange 2007 on vSphere 4, we saw virtualization overhead of about between 2 to 5%. And we continue to see that number drop with vSphere 5. So Microsoft still has a blanket statement on TechNet that says 10% is a good number for virtualization overhead. So going back to it, it's hard to quantify exactly, what does, if I choose to deploy an environment with 2 to 1 CPU overcommit, how do I actually calculate that? So first, during the design process, we do not want to use any or assume any level of processor overcommitment, processor core overcommitment. For things like the client access servers, hub transports, which can use tools like DRS and vMotion, typically a lot better than, say, a DAG node. And really, I only say that because those roles tend to be a little smaller. Down the road, we might be able to leverage some overcommitment. Definitely, this is an area where we can leverage overcommitment much more easily than in memory, in the perspective of memory, which I'll get to in the next slide. But again, when we're going down these designs, we factor no overcommitment. Definitely enabling hyperthreading, if for nothing else for ESX, right? Letting ESX use its scheduler to make better decisions because it sees it has more places to locate those threads. There's a lot of discussion also from Microsoft around whether or not that should be done, and I'll show a slide coming up next. NUMA, so most of the hardware is going to be NUMA capable. ESX is NUMA aware, and ESX will do its best to keep NUMA workloads, or to keep workloads which are able to be placed within a single NUMA node local. So they can take advantage of having the memory as close as possible to the processors they've been assigned to, and not have to go over to the next NUMA node for remote memory access. Now, with vSphere 5, we exposed virtual NUMA, which means that we can now expose the NUMA constructs up into the virtual machine. And for applications like SQL, this really makes sense because SQL is NUMA aware and can take advantage of that. Exchange is not NUMA aware, but we can still take advantage of this, and I'll get to that in a couple slides here. And then finally, making sure that we understand the CPU requirements from an Exchange perspective and what it is that our proposed CPU hardware can actually can sustain. So Microsoft has a tool called the Processor Query Tool, and that tool is an Excel spreadsheet which just goes out to the spec website. You can plug in the exact processor model that you're looking at, and it'll go out and come back with the details of that processor, and it'll even come back with a listing of server models that they've tested and what their rating is. That number goes directly into the Exchange Mailbox role calculator, and that's where you can actually see, okay, how many processors or processor cores am I going to need based on this processor, based on that processor? So back to the hyperthreading confusion. You know, the only reason that I can, and I've read this a bunch of times on TechNet, and it seems to be pretty clear to me, but Microsoft is basically saying when you factor in hyperthreading, it makes calculating the size of the environment difficult. Well, yeah, if we can get through our heads, and it's not a very hard concept, but if we can get through our heads that a logical thread does not equal a physical thread, then the calculations aren't really that difficult. So what we believe is, for ESX's sake, we want to enable hyperthreading, but during the design phase, we want to make the assumption that hyperthreading is turned off, right? So if I have that 12-core processor and it's 12 physical cores, I'm going to design to 12 physical cores. Now, whether or not I enable hyperthreading at that point, you know, I can definitely not enable hyperthreading, and I will know that as far as the workload that I've calculated for, the hardware should be sufficient. Now, if we look at some of the vSphere performance best practices that tell us that, you know, we can see an increase of anywhere from between 15 to 25% when enabling hyperthreading, well, that's a little bit more bang for our buck that we've gotten there just by enabling it. And we weren't confused during the design process as Microsoft thinks we might be. So enable hyperthreading. So from a NUMA perspective, I always get the question, I always spout off about NUMA for a while, and then I get the question, you know, what's NUMA, what do I care? And if Exchange doesn't know about it, then why does it matter? Well, take this here. So I have basically this, assume this slide is a server, and I have two sockets. Each socket has a processor with 4 cores on it. Each of those sockets is going to have direct access to the memory that's in its memory bank. And whenever my process runs on that socket, on any set of those cores within that socket, I'm going to be able to access that memory very quickly. A lot faster than it would be for me to access the memory on the other memory bank across the NUMA node. Now, what are we talking about here? We're really talking about a performance improvement of about 5%, according to our performance team. So the point here being, the virtual machine on top has been allocated 4 virtual CPUs and 32 gigs of RAM. ESX is going to do its best. Now, it's not guaranteed, but ESX will do its best to keep that VM scheduled within the NUMA node on the left, or either one of the NUMA nodes, right? But within the NUMA node. And that memory access will be local. If I go with a larger VM, I will have what's called a wide VM, a wide NUMA VM, and I'll have to do some remote memory access. Now, again, I'm not trying to say that this is going to be detrimental to the Exchange environment you're designing. What I am trying to say is that you can get about a 5% performance improvement by keeping memory access local. However, and when possible, that's great. However, there are many environments that we work on that are supporting 150,000 mailboxes, 300,000 mailboxes, 750,000 mailboxes. And it doesn't make sense to deploy a mailbox server that can only support 3,000 users, right? We need to be able to support larger. And so that's fine. And there's been continuous performance improvements to make sure that these wide NUMA VMs perform well. So a lot of these best practices are really focused on eking out that last 5% of performance that we can get out of the actual hardware. So some quick points on NUMA. Make sure it's enabled. That's typically enabled by disabling node interleaving. That's pretty much a default configuration within the BIOS. When possible, size the Exchange VM to within the NUMA node. If it doesn't make sense, don't do it. Who wants to manage 20 mailbox VMs when I can manage 10? At that point, we really need to take into consideration management versus what could be maybe a 5% improvement in performance. I showed you an example where the socket had a 4-core chip in it, and that was the NUMA node. That's typical of maybe the Intel architecture and the 6-core and 8-core chips, 10-core chips. A couple of years ago, AMD came out with the Magni cores, and those were 12-core chips, 12 cores in a single socket. However, they were actually 2 chips, kind of piggybacked on top of each other. Those were individual NUMA nodes. So the number of cores you have within a socket does not necessarily mean that that's the NUMA node. Understand the processor architecture if you're looking to take advantage of that. From a memory perspective, more so than on the virtual CPU slide, memory overcommitment at this level, of business critical application, could really be detrimental. All right, we're not trying to cram in as much exchange into a piece of hardware as we can. We're trying to make our business processes better. We're trying to make better use of the hardware that we're using. We used to talk a few years ago about consolidation. We have to get some better story around consolidation numbers of exchange, and I'd say no. But I mean, that's really not the point of virtualizing something like Exchange or Oracle or SAP. The point is to, again, better align with what the rest of the data center is going through, right? So memory overcommitment, definitely a bad thing. More so for the Exchange, for the mailbox role than for anything else. A couple of ways to get around this. Reservations. So I don't like reservations because I think it's a management headache. I don't like having one-offs in the environment. I like to keep things pretty consistent among all VMs as much as possible. But if you're in a shared environment, maybe more of you're a tenant in an environment, or you're providing an environment for tenants, providing a service where you might have to guarantee physical memory availability, reservations might be the only way of doing that. Another reason for reservations might be to make sure that that swap file that gets created every time a VM is powered on isn't just sitting there gobbling up disk space. A lot of these Exchange VMs have 32, 48, 72 gigs of RAM. And every time you power them on, they're going to allocate that much in a swap file for VM swapping. Creating a reservation will eliminate that. That tends to be more of an issue in environments where we're using data replication, perhaps for like SRM. The third bullet here, the fourth bullet. the more memory means less IOs, but not really. I really put that in there because we did a study a few years ago with Exchange 2010 with vSphere 4.1 where we created a VM to support 8,000 mailboxes. Now, we created this VM per the Microsoft best practices per the calculator. We gave it 72 gigs of RAM, and as expected, it ran fantastically. We then started taking memory away. And as you would expect, what happens, you take memory away, we need to go out to disk more often, we generate more IOs. Okay, fine. Well, what we noticed was that the increase in IOs wasn't very significant. We're talking about, for these 8,000 users, we're talking about 1,400 IOPS at 72 gigs of RAM to about 1,600 IOPS when we dropped the memory to 16 gigs of RAM. So 200 IOPS, and we're saving a whole lot of RAM. Now, of course, if you tell this to your Exchange admin, they're not going to listen to it at all. But it's there. You can download the paper from VMware.com. And, you know, all I'm really saying is memory is one of those commodities within the ESX boxes that we want to be a little more mindful of how we allocate. If we can save a few here and there, maybe it's not such a bad thing. So storage is always fun. So I have a few slides on storage. First of all, from a multi-pathing, path redundancy perspective, has anyone here seen the Microsoft, the MSCS guide that VMware publishes with every new version of vSphere? It basically lists all the restrictions when you deploy a Microsoft cluster on vSphere. One of them is no round robin, only use last known path or the last path that was used by the target. Not so much the case for DAGs. So DAG is not a shared disk technology. Basically, all bets are off. You are free to do what your storage vendor says is best for your performance needs or your availability needs. When creating, and most of this goes along with the mailbox role, but if you're deploying the hub transport role, which also has a database, you can use these same rules basically apply. NTFS partitions. When we're formatting those from within the guest, from within Windows, use a 64K allocation unit size. That's best practice for SQL as well as for Exchange. Verify the partition is aligned seems like an old point to have in here because, of course, we're all running Windows 2008 and Server 2012, and everything's aligned by default. But there was an interesting note from on MSDN from the SQL developers, which had come about because they were seeing an increasing number in tickets around performance, even on Windows 2008 OSs. And ultimately, the cause of all this was misaligned partitions. So they threw that note in there. They thought it was important from a performance perspective, so I throw it up here. Eager zero thick. So if you have a performance, an IO-intensive workload, and you want to get the best performance from a virtual disk perspective, or when you're deploying on virtual disks, you may have heard you want to eager zero thick the virtual disk. Yeah, I'll go with that. The reason why, and again, if you don't know what an eager zero thick virtual disk is, basically at time of creation of the virtual disk, we're going to go through and zero out every block of that virtual disk that's going to be presented to the VM. And what that means is that from within the VM, when you go to write to a block for the first time, you don't have to zero it out and then write your data. You just write your data. So the implication is it takes longer to present that disk to the VM, but it's at time of creation of the VM. I'm assuming you don't need it immediately. It takes a very long time for very large disk. 1, 2 terabyte VMDK is going to take a very long time. Where I see this being a good fit for something like Exchange is in large migrations. So you're going to create a target for potentially a few thousand mailboxes, and you're going to start doing, or someone's going to start doing a lot of mailbox moves. That's all going to be new data. It's all going to be new data on fresh disk. After a couple years of running in an environment, you're not going to see any huge performance benefit there. And then from the vSphere Performance Best Practices Guide, directly from their mouth, setting power policies within vCenter to high performance or actually going into the BIOS and disabling any performance features altogether. Typically what ends up happening is these performance features, when they kick in, tend to affect the I/O path, so storage and networking. So some of the common questions. PVSCSI or LSI logic? Well, for me, it's really a matter of how are you managing your environment. Have you standardized on PVSCSI? Or is most of your environment just using default LSI logic? If it's mostly LSI logic, then unless you have gone through the paces of taking your proposed exchange configuration and doing something like jet stress, and you see a significant improvement between PVSCSI and LSI logic, then I would say, well, stick with the LSI logic. If it's gonna, if it's gonna, I mentioned earlier that I don't really like change between large sets of VMs unless it's really called for. Now, what the PVSCSI driver is gonna get you is increased IOPS, potentially at a reduced cost at the host level, right? So we're not having to use as much processing at the host level to get this data through. Again, all of our partners do testing typically with LSI logic, and it works absolutely fine. So I would take it from a management perspective. Again, unless testing has shown that you can see some significant improvement. More virtual SCSI adapters. So it used to be that we would recommend, take vSCSI 0 and put your OS and your apps there. Take vSCSI 1 and put your database there. Take vSCSI 2 and put your logs there. When playing around with various vendors and trying to do these jet stress evaluations, we noticed that when we start evenly distributing the data disks among all of the virtual SCSI adapters, and you get up to 4 per VM. When we start evenly distributing those among the virtual SCSI adapters, we can actually get significantly better throughput. So there's really no reason why we should be, keeping it to a specific traffic type per vSCSI adapter. We want to use all SCSI, and this is mainly, again, we're talking about the last 5% of performance that we're going to get out, but in some cases it can be pretty significant. VMDK and RDM takes up a whole slide, so we'll do that next. And then, what about one virtual disk per VMFS? Can I co-locate many virtual disks on a single VMFS? Typically, you'll hear from, if you go to the SQL presentation, if you go to the Oracle presentation, you'll hear, if you're going to go with the virtual disk for data for this business critical app, you probably want to locate one virtual disk per VMFS. And some of the thought behind that is really around governance and control of the environment. You might have a very large VMFS partition because you just had you needed a lot of spindles behind it. But you may not need all of that space. So you end up creating a small virtual disk file. Well, what you end up with is a lot of free space that some other admins can come and start plopping their VMs on, and now you can have some contention, and your business critical app, whatever it is, in this case Exchange, begins to suffer because someone else, you have the noisy neighbor effect, right? So that's a valid case for single virtual disk per VMFS. On the other hand, if you have many, many databases and logs and you want to try to isolate those onto their own drives from within Windows and make it more manageable from within Windows, you might want to go down the route of creating, again, that single VMDK for your database, single VMDK for logs, but you may not want to have all of these LUNs exposed up to the ESX host because, of course, we have a LUN limit within ESX, right? We can only allocate up to 255 LUNs per host. Effectively, that becomes a per cluster limitation. So co-locating for that purpose is definitely valid, especially for Exchange. We see a lot of designs where we have hundreds of database and log LUNs, and it just doesn't work with RDMs, or it doesn't work with isolating those virtual disk files to a single VMFS partition. So just really quick, RDM versus VMDK, it's not a performance issue anymore. Typically, unless you're doing array-based backups, right, snapshots and clones using hardware VSS, there doesn't really seem to be any other real reason to go the RDM route. NFS, not supported, but I've seen plenty of customers doing it. Some Microsoft Premier customers are doing it and say they don't have any support issues. It's not supported, but it does work. From an ingest iSCSI perspective, we do have a lot of customers going that route as well. So the LUNs are actually zoned directly to the guest OS, and this bypasses ESX. This is also a way that you can get around the array-based backups without going the RDM route. So many of the vendors you can take their agent, their backup agent, install it within the guest, and if that guest is attaching to the LUNs using ingest iSCSI, you can get your backups the same way you would in a physical environment and the same way you would have if you were doing RDMs, but you don't have the management overhead that an RDM presents. And you can actually avoid a lot of the LUN limitations, that 255 number of target LUN limitation. From a networking perspective, really nothing specific to Exchange. The one thing that comes up for Exchange is around, if I'm doing a DAG, how many NICs should I allocate to those DAG nodes? Can I do one? Should I allocate two? Do I need one for my MAPI or client traffic and one for replication? Microsoft supports a single NIC for the DAG node. It recommends 2 NICs. We recommend 2 NICs. Just in working with Exchange, I've seen some anomalies where the VMs only have 1 NIC. So we recommend 2. And separate the traffic types, right? We want to make sure that the reason we're allocating a MAPI NIC and a replication traffic or a heartbeat NIC is to make sure that the DAG nodes understand what type of failure we've encountered. We have a network failure, the whole server went down, and it uses those communication paths to understand that. From the ESX perspective, we definitely want to keep with those best practices. So separating management traffic, data access traffic if we're doing something like iSCSI, and vMotion traffic in particular. So a couple ways to do this from the perspective of the DAG node. Many systems are now just shipping with a couple of 10 gig NICs. And in this scenario, we would go with a VLAN tagging approach to logically separate that traffic. In some cases, we can actually begin to add QoS to that traffic. If you have an older server, or maybe you're still deploying these rack-mounted servers with multiple NICs, then perhaps you go with the solution on the right, where you're actually physically separating the traffic between management, vMotion, any data access, and your virtual machine traffic. So from a high availability, and this is vSphere high availability perspective, definitely enabling HA is one of the first things we would recommend. Having the DAG there for databases is fantastic. If we deploy in the way that we would design an environment for Exchange, we would have an N+1 configuration. And typically in that scenario, N is the number of DAG nodes. In an N+1 scenario with vSphere HA, if we lose a host, and we lose a DAG node that was running on that host, we can bring that DAG node back up on a surviving host. Now, the databases will already have failed over. Users will be accessing the now active database. But by having that host, that VM, get powered on another host with vSphere HA, we're allowing that Exchange replication traffic to again commence. And we are protected faster than we would have been if I have to wake up at whatever hour and figure out what's going on, power that VM on somewhere if I have somewhere to power that VM on. And a few points. Admission control is configured so that we have failover capacity. We can guarantee that we have failover capacity. We don't have VMs getting powered on within this environment that violate our capabilities for maintaining the performance level in the case of a host failure. VM monitoring, I like it enabled because it gives me the opportunity for, maybe not the DAG nodes, but it gives me the opportunity for things like the CAS servers, hub transports, any other VM that's running, to establish some level of understanding of what's going on within the VM, right? Those VMs have VMware tools. vSphere HA connects to VMware tools, establishes a heartbeat. If that heartbeat goes missing, vSphere HA will look at the I/O pattern. Is there still storage I/O? Is there still network I/O? And if all those have failed, we can probably safely assume that the VM has also failed, whether it's a blue screen or it just froze. vSphere HA can then give that VM a kick and help bring those services back online. Very helpful for applications that don't support any level of clustering. So from a DRS perspective, again, enable DRS, but really understand that the environments that we look at don't ever rely on DRS as much as high consolidation environments, view environments, right? VDI type environments. Really what we're using DRS for is placement at power on, adherence to rules during those power on operations, right? If I have anti-affinity rules against my DAG nodes, I want to make sure that when they're powered on, they're not powered on the same host if they're in part of the same DAG. And maintenance mode, right? If I'm a vSphere admin, I want to be able to put a host in maintenance mode without having to pick up the phone and call the Exchange guy to have him shut his VM down. Keeping VMs small, relevant when we're looking to take advantage of DRS, right? The DRS engine is going to be able to make better placement decisions with smaller VMs. Smaller VMs can fit into have slots more available, highly available for placement of those VMs than a larger VM would. And then the last one, really to ensure the compatibility of vMotion, making sure that our hardware is compatible across the vSphere clusters. I was talking to a customer yesterday who their practice was as soon as they got a new host to just add it into the cluster. And this meant that they didn't really have a whole lot of options for vMotioning. EVC can help, but not very popular. I mean, you end up, going with the lowest common denominator of functionality for your processor by enabling EVC. So what I like for EVC is it helps avoid people adding in non-compatible processor architectures. So we have DRS, VM, and host groups. I like to use these guys for, the host groups I like to use for localized ESX hosts. Say host in a chassis or host in a rack. Group those hosts together, and especially useful if I have a vSphere cluster that spans multiple chassis, multiple racks. VM groups, typically used for grouping like types of VMs. So maybe a set of my client access servers, a set of my hub transport servers. And I'll show an example in a minute. DRS rules, so we have our affinity and anti-affinity rules. For DAG nodes, we would use anti-affinity rules, keep DAG nodes from the same DAG separate. And then we have VM to host rules. So where can a VM actually run? There's must run on, must not run on, should not run on rules. For things like client access servers or non-clustered VMs, we like the should run on rules. I'll show you why. So in the top here, the dotted line is my way of creating a should run on rule. So I can have two sets of hosts there within the same vSphere cluster, but maybe they're not, they're in different racks, different chassis. My should run on rule says that the VM on the left-hand side here, on the top of the left-hand box, should run on that set of hosts. During a failure, that should run on rule means that that VM can be powered on somewhere else. In a must run on scenario, like the one at the bottom, a failure of that host means that that VM can't be brought online anywhere else. Where this bottom scenario actually works out pretty well is in licensing situations. Right? So if I have to license the underlying physical hardware, I might not want to create a small cluster dedicated to whatever application I'm licensing for. I might want to segregate a small set of my larger cluster for that purpose. So vMotion and DAG nodes, being that this is now supported, right, as we talked about earlier, support is great, but what good is it if it doesn't really work so well? We did a whole bunch of testing last year and found out that we can vMotion the DAG nodes, but every time we vMotion, we started getting database failovers, rather. After a lot of trial and error, we came to a conclusion that we were actually, the stun time that the vMotion creates during that final movement of the last few pages of memory to the other host was causing the cluster heartbeat to fail. So we had two workarounds. The first one was enabling jumbo frames. This isn't the greatest solution because it needs to be supported end-to-end within the environment that this is running in. Very hard. If it's not already there, it's typically a hard change to implement. Not an easy sell. But it worked. The next one was to increase the heartbeat interval. So instead of sending a heartbeat every second and allowing for 5 failures, which is default, we would set the interval to every 2 seconds, which would increase that time to about 10 seconds. That also seemed to get rid of a lot of the database failovers, majority of cases. And this was all on gigabit network. 10 gigabit, we still saw some failures. What we ultimately found fixed us in about 100% of the cases was dedicating vMotion interfaces and using multiple vMotion interfaces. Really the second one more than anything, using multiple vMotion interfaces. Now this is something that's supported in vSphere 5 and basically allows us to get an aggregate of the bandwidth that's available for the vMotion interface. vMotion traffic actually goes down both NICs simultaneously. So in a common scenario, in a common configuration here, say just for our VM kernel management port, you would see that if I highlight the VM kernel port on the left, you can see what my active VM NICs are on the right. In this case, they're both active. To configure vMotion to use multiple NICs, we would have to create a new port group. However, we'll set one VM NIC to active and set the second or any subsequent VM NICs to standby. On the next port group, we would do exactly the opposite. That's all the configuration that's needed. Again, this is a vSphere 5 feature. But with this configuration, we were able to see about 100% success rate in DAG node vMotions without having databases actually fail over. So really quick on backups, we talked about virtual machine backups, making sure that there's an agent there to do all the exchange, quiescing, and whatnot. Software VSS, which is the most widely deployed method of backing up Exchange databases, usually, again, an agent within the VM. And then hardware-based VSS. Protection at the array level. The storage vendor will provide the VSS integration. In most cases, actually, raw device maps are required. So just a couple more slides here, then we should have a couple minutes for some questions. So site resiliency. Typically 2 options that we propose in a design. Exchange native resiliency. In this solution, we have a high availability copy in the local data center. So we have log shipping going there, and probably a third copy in a remote data center. And this is for all nodes. Vice versa for the other side if we have active users there. In a failover scenario, we manually activate the databases in the secondary site. Now, those databases, unless we've allocated more storage, typically those databases would not have any protection at that time. Also, in most cases, the method of failing back would result in us having to reseed the entire databases back over. Really depends on how the administrator went about doing that failover. The steps are very specific to Exchange. The Exchange administrator has to go in and basically bring the cluster down, evict the nodes that we can no longer get to so we can establish a quorum, bring services back up, make some DNS changes, very application specific. But that is one, and that's probably the most popular method of site resiliency with Exchange 2010. An option that we've deployed in a few customer sites where they actually want to just go ahead and be able to migrate the entire DAG. So this gives them the capability of, during a failover scenario, actually maintain the same level of high availability in the target site. On top of that, the process of doing this, and I'll just click through this animation here, the process of doing this is not specific to Exchange. In fact, the only Exchange portion that's involved is updating of the DAG or cluster IP address. And really, that can be all scripted from within the SRM run recovery plan. So this actually from end to end can be completely scripted within SRM so that anyone with the access could go in and run this recovery plan. You know, when trying to pick a method, we really need to focus on who's going to be doing the work, where do we want that work to happen. I think more importantly, how do we test the solution? In the Exchange native design, testing of the failover means actually failing over, impacting production. In the Site Recovery Manager design, we can actually test, bring over the VM. We're not bringing over anything. We're really just making storage writable and presenting it to ESX hosts. But we can execute that recovery plan, bring VMs up, isolated within a network so that they don't get out, of course, and make sure that databases come online, make sure that Outlook connects, make sure that OWA connects, et cetera. Make sure that you can send and receive mail. To me, that's one of the important features that I would look for in a site resiliency model. That said, they both work, they're both supported. So moving on, a couple of takeaways. Of course, we know this is 100% supported now by VMware and Microsoft. You know, like I kind of drilled in at the beginning, virtualization doesn't have to change the design of Exchange, absolutely doesn't change the compute requirements. It just gives us a few more options on how we deploy and how we make use of that underlying hardware. Really quick, I know there's a lot of information here, and I'm sure you guys have been at VMworld in the past and know it takes a couple weeks to get these presentations. This presentation is actually available on Socialcast now. So if you have not signed up, go to vmworld.socialcast.com, sign up. You can search for my name. You can search for the number of this session. You can search for Exchange. But you can actually download the presentation immediately. So with that, we do have a couple minutes. If anyone has any questions, you can come up to the mic, come up to the stage. I'll be around for a couple minutes. Thank you very much for coming.